go ahead and look at an extension on our lesson 3, our systems of equations, solving via elimination. We've already solved systems of equations with eliminations already. We're going to go ahead and take a look at the next step. This time, we're going to learn how to solve a system of equations using the elimination method without a common coefficient. So, the first time, common coefficients look something like this. 3x plus 4y equals 12, and negative 3x minus 4y equals 7. We have common coefficients, ones that are exactly the same. So without a common coefficient, we might look at something like this. X plus 3y equals 7, and 4x minus 2y equals 2. Now you can see neither of them have the common coefficients. 2 and 3 are different, 1 and 4 are different. We're going to learn how to solve this type of problem today. Okay. So let's get started. So let's take a look. What we're going to do, our steps are to multiply one or both equations by a number that creates matching opposite coefficients. So a couple of things I mean by matching opposite coefficients. Matching might be negative 3 and positive 3. They're matching, but also opposite in value. Okay? And when I multiply one equation, I'm only going to change one. If I multiply both equations, that might come a little later. So let's take a look at number 1 in our notes. So on this problem, we have two numbers. We have coefficient here of 1 and 2, and 3 and 7. Now, what I want to look for is which pair makes the lowest common multiple. So here, if I found the lowest common multiple of 3 and 7 would be 21, and my lowest common multiple of 2 and 1 would be 2. It makes the most sense to multiply our first one to make sure, because this is the lowest common multiple between the two. And I already have a number that doesn't need to change. If I multiply the top equation, so to do this, we're going to multiply our top equation all the way across by 2 and creating a brand new equation that's equal to it. So let's take a look at what that would look like. So we distribute the 2 to every single coefficient and number in the equation. So 2 times 1 gives us a new equation of 2x. 2 times 3 gives us a coefficient of 6y. And 2 times 6 will give us a number of 12. Now, that doesn't give me the opposite coefficient that I need. I need that opposite coefficient. So the best thing I'm going to do is actually multiply not by just 2, by negative 2. So that changes this 2 from positive 2 to negative 2. This 6 from positive 6 to negative 6. And this 12 to negative 12. So now I'm going to walk through and do my work. So now I've got two coefficients that are common, just like I did last unit, and they're opposite. So if they're opposite, because they're different signs, we're going to choose to add. So 2 plus negative 2 is 0. Negative 7 plus negative 6 is negative 13y. And then negative 1 and negative 12 is negative 13. So that gives me an answer. If I divide both sides by negative 13, I get y equals 1. So now that I have y, I can go back and plug that in and to one of the equations. So x plus 3 times 1 equals 6. So x plus 3 equals 6. Subtract 3 from both sides. I get x equals a positive 3, giving me a final answer for this problem of 3, 1. Let's take a look at another equation, just like this. So let's take a look. This is number 2 in your notes. So this time I'm going to look at my two equations. Again, I've got 9 and I've got 2, and I've got 3 and I've got 1. if my lowest common multiple of 9 and 2 is 18, my lowest common multiple of 3 and 1 is 3. So that's the one I'm going to choose to multiply. Now, they're both positive, so I want to turn them into opposites. So I'm going to multiply by -3. So I'm going to follow that equation. -3 times 2 is -6x. -3y equals -15. So now this equation, we're not even going to look at it anymore. I find it easiest to just rewrite both equations so that I don't get mixed up with any of this information. So now that I have this, I've got equal and opposite coefficients. I have two coefficients with different signs. So I'm going to set it up to add. -6 and +9 is 3x. And, well, -3 and +3 cancel out. That's 0. And -15 and +12 gives me -3, leading me to an answer of x equals -3. Now, if I keep going, I plug -3 into another operation. So I'm going to plug that into let's plug it back into, let's say, the first equation. It doesn't matter. I can plug it into either. But 9 times 3 plus 3 times y equals 12. So 27 plus 3y equals 12. Subtract 27 from both sides. And I get 3y equals -15. And that makes y -5. Now I bet you're asking, why didn't I plug it into the second equation? No reason. I happily could have plugged it into the second equation, and actually that probably would have been my preferred equation. It has a y all by itself. It saves me some time when I multiply and do the work. Either way, I'm going to get the same answer. So let's go ahead and finalize this answer. X is -3, and y is -5. All right, let's take a look at numbers 3 and 4, or at least number 3. What pair, just like we've been asking before, which pair can be made common coefficients equally and easily? Well, we have 3 and 5 is 15, and 1 and 4, well, that's 4. This is going to be your easiest pair right here. Now let's look at my signs ahead of time. I've got negatives. I've got that opposite pair already, so I don't need to multiply by a negative. So I'm just going to multiply everything by 4. So let's go ahead and do that. 4 times 3 is 12. X minus 4y equals 56. So it gives me a slightly larger number, but that's okay. So now we're going to go ahead and do our math. Add all our information up. 5x and 12x. That gives me 17x. -4y, +4y, well, that gives me 0. And if I add the next two up, I get 68. Well, if I divide both sides by 17, I'm going to get the answer x equals 4. Now that we've got that, what do you think is the best one to plug this x back into? You're right, it's going to be going back into that first equation right here. It already has that y solved by itself. It allows me to do a little less work. So 3 times 4 minus y equals 14. 12 minus y equals 14. Subtract 12. Negative y equals 2. Divide everything by -1. And y equals -2. So I get my answer of 4, -2. That's the intersection point. Okay, let's take a look. I'm going to pause the video. Why don't you pause the video right now, and each of you try 4 and 5. Feel free to work with your partner, your person next to you, and get help if needed. And then you can start the video again, and I'll go over both answers. Okay, well, let's take a look and see how you did on your work. So, first one, number 4, you can do either equation. You can solve for 5, you could solve and multiply x or y. I'm going to choose to multiply y. If you chose to multiply x, let's see if we got the same answer. The reason I chose y is I already have that equal opposite pair. I've got the opposite pair right here. I just need to make them equal. So I'm going to choose to multiply everything, the top equation, by positive 2. So 2x plus 2y equals negative 6. Now I'm going to put all this stuff together, and I'm going to get 7x. I'm going to add all of it together, and I'm going to get 7x equals negative 56. So now, dividing both sides by 7, x equals negative 8. Plug x into the first equation, negative 8, plus y equals negative 3. Add 8 to both sides, and y equals positive 5. So negative 8, positive 5 is the answer. Hopefully you got that problem. If not, take a look at your partner, see if you guys can figure out where you may have missed a sign or missed an answer. Let's take a look at number 5 and check that one as well. Now in this case, I don't have the luxury of the opposite pairing already, so I'm going to have to choose to think my way through and go, okay, 2 times 3 is 6. That's a pretty relatively low number. Or 3 times 1. Well, 3 times 1 is my smallest number. But I'm going to have to remember to multiply it by negative 3 because I need this set right here to be opposite each other. So negative 3 times 2 is negative 6x. This becomes positive 3y, negative times negative, equals positive 15. So now I've got my equation. I'm going to go ahead and rewrite the other one down below, just so that it helps me see what I'm adding together. So here's my new equations. Negative 6 and positive 3 added together gives me negative 3x. Positive 3 and negative 3 give me 0. And 15 and negative 3 gives me a positive 12. Leave me with x equals negative 4. With x equal negative 4, I'm going to plug it back into either equation. I'm going to choose the second equation this time. So 2 times negative 4 minus y equals negative 5. So I multiply, I get negative 8 minus y equals negative 5. Add 8 to both sides. Now I'm going to negative y equals 3. Divide both sides by negative 1. And I get y equals negative 3. With a final answer of negative 4, negative 3 as my intersection point. All right. Now let's take a look at another structure of problems. Let's take a look and see if we can find, what if we can't find just one where I can multiply a single equation? Let's jump to number 8 in your notes. What if I can't find just one? So if I multiply 3 times 5, I get 15. That's my lowest common multiple. 3 times 4 gives me 12. Well, neither one of these I can create a common multiple. They're both going to have to be changed. If you can't just multiply one equation, you're going to have to multiply both. Well, to multiply both equations, you're going to do the same thing you've done in the previous problems. You're just going to have to do it twice. So doesn't matter in this. We have the same signs on both of them. So 12 happens to be smaller. And let's go ahead and let's get rid of our y variable. So my first equation, I'm going to have to multiply, let's say, by negative 4. My second equation, I have to multiply by positive 3. This will let me have that opposite pairing. So negative 4 times 3 is negative 12x minus 12x equals negative 36. And now I'm going to multiply 3 times 5 is 15x. Then we get a positive 12y. And we get a positive 30. So now I've got my equal opposite pairing. So I'm going to go ahead and add them together. So positive 12 and negative 12 and positive 15 is a positive 3x. Negative 12 and positive 12 is 0. and negative 36 and positive 30 gives me an answer of negative 6. So I divide both by 3, and x equals negative 2. Now that I have x equaling negative 2, I can plug it back into any of my 4 equations. This one, this one, this one, or this one. It doesn't matter which one you plug it into. I'm going to choose the ones just with the lowest, smallest coefficients. So I'm going to pick equation number 3. So 3 times negative 2 plus 3y equals 9. So negative 6 plus 3y equals 9. Add 6 to both sides. I have 3y equals 15 now. Divide both sides by 3, and you get y equals 5 for an answer of negative 2, 5. Okay. Now I want you to give number 9 a try. Go ahead and pause the video. You're welcome to work with the person sitting next to you as you work through this problem. Restart the video when you're ready for me to go over the answers. Okay, let's take a look at this one. So again, either way I multiply, I'm going to have a lowest common multiple that's going to be relatively large, but that didn't seem to matter last time. So let's go ahead and check. So my lowest common multiple of these two numbers is 35, and my lowest common multiple of 9 and 10 happens to be 90. Those are both pretty large numbers, but 35 is smaller, so I'm going to multiply and get rid of the x's this time. Do I have the opposite pairing? No, they're the same, so one's going to have to multiply negative. Let's do this one negative. So what do I multiply 7 by to get to 35? Well, negative 5. And 5 by, I'm going to multiply 7. So let's rewrite those equations now. 5 times 7 is 35x. 7 times 9 is 63y. And then 7 times negative 10 is negative 70. And we go ahead and keep going now to the second equation. Negative 5 times 7 is negative 35x. Negative 5 times 10 is negative 50y. And negative 5 times negative 1 is positive 5. All right, so let's take a look. Let's finish this problem. So let's put these two together. I've got my equal and opposite, so I'm going to add different signs. So that gives me 0x and leaves me with positive 13y. 63 minus 50. Negative 70 and 5 leave me with negative 65. Well, this time y equals negative 5. If I divide both by 13, so if y is negative 5, I'm going to plug it back into the next equation. It doesn't matter if you plug it back into equation 1, 2, 3, or 4. They're all going to give you the same answer. But in this case, I'm thinking I'm going to plug it back into equation 1. It just has the smallest y coefficient. So 5x plus 9 times negative 5 equals negative 10. So 9 times negative 5 is going to give me negative 45 equals negative 10. I'm going to add 45 to both sides. And that leaves me with 5x equals positive 35. If I divide both sides by 5, I get x equals a positive 7, leaving me with a final answer of 7, negative 5. Good job on that one. Now I've got one more twist. I always do. So let's take a look at one like number 10. My question I want to ask you is, what do you have to do first? What must be set up before you can solve this problem? I know you're saying to yourself, I got to line it up. And that is true. You got to line it up. All your equal signs, all your x's and y's all have to be lined up together for it to work. Specifically in this case, my equal signs need to be lined up. So I'm going to take a look at the equations. I want to move y to this side of the equal sign. And to do that, I've got to subtract 4y from both sides. Gives me a new equation of positive 2x minus 4y equals 18. Now in this case, again, I don't have ones that I can easily make opposite. I've got 6 and 4, which my lowest common multiple could either be 12 or 24, or I have negative 5 and positive 2. Now, negative 5 and positive 2 give me a lowest common multiple of 10, and if you look carefully, you've already got that equal opposite pairing. You've got a positive 2 and a negative 5. That lets me multiply them without having to worry about which one do I have to be negative. So to get 5 to 10, I'm going to multiply this equation by 2 and this equation by 5. So negative 5 times 2 is negative 10x, and negative 6 times 2 is negative 12y, and 3 times 2 is 6. My next equation, 5 times 2 is positive 10x. 5 times negative 4 is negative 20y. And then 5 times 18 is 90. So let's go ahead and work through the problem. Now we're going to add them together. This time I'm sitting over here with uh, 0x. Sorry, lost track of what I was doing. This gives me 0x, and this one gives me a negative 32y. And this side giving me a positive 96. Now, let's see if 32, so we divide by everything by 32. And when we do that, y equals a negative 3. Even with large numbers, it simplifies out to be a whole number. So now I'm going to plug this y back into one of the equations. Doesn't matter which one, but again, I think I'm going to lean towards this one. This original equation right here gives me the easiest way to work it. So 2x minus 4 times negative 3 equals 18. So negative 4 times negative 3 is positive 12. 2x plus 12 equals 18. Subtract 12, leaving me with 2x equals 6, and x would be equal to 3. So our final answer of 3, negative 3. All right, it's your turn to try number 11. Once you try number 11, you can start your homework. All right, I'm going to go ahead and tell you how to solve it after you unpause the video. Okay, first thing we need to do is set this one up and make it equal again. We have two equations that are not the same. So to do that, I'm going to add 6y to the bottom equation, because then I can move this one back to standard form. It'll make it easiest to work with. 2x plus 4y equals 6. And now I have 3x plus 6y equals 12. Now my lowest common multiple of this set is 12. This side is 6. So I think I'm going to multiply and get 6. So to get the equal pairing, this one's going to be multiplied by 3 and this one by 2. And I'm going to go ahead and multiply also here. I'm going to add the negative, so I get the equal opposite. So now I get negative 6x minus 12y equals negative 18. And on the next problem, I get 6x plus 12y equals 24. So as I finish this equation, I'm going to add them both. Negative 6 and positive 6 is 0. Negative 12, positive 12 is 0. This one is 6. So when two numbers don't equal each other, it's not possible. Therefore, it makes it a no solution. Good job. I look forward to working with you on Tuesday, and we'll take a look, review this real quick, and move on to the next idea.